All right. So we want to look at using differentiation to find the turning points of curves. So whenever we have quadratic curves, we have these two turning points. A quadratic curve has only one turning point. A cubic curve has two turning points. And what we know about the turning points, we know that the gradient is 0. So this is one fact you must know. At the turning point, the gradient is 0. Okay, so I'm going to combine this with our introduction to differentiation lesson from yesterday. Differentiation is used to find gradients. So let's look at a case study. Okay. So find the gradient of this curve y equals x cubed plus 2x at a point x is equal to 4. So if we want to find that gradient, this is how you do it. Step 1. The first step is to differentiate. So we have y equals x cubed plus 3 plus 2x. If we differentiate that dy dx, Melissa, what will be the answer?
3x to the power 2 plus 2.
Excellent work. So that's the first step. And then number 2, step 2 will be to actually find the what? Find gradient. So you need to substitute the given point into your derivative or into your answer. So if x is equal to 4, then our dy dx is going to be 3, 4 squared plus 2. And then you can use your calculators for that. What are we going to get?
50, sir.
Okay, excellent work. So a key takeaway from this lesson is that if you're looking for gradient, you do substitution. You differentiate your function. After that, you just plug in the x value of the given point to get the gradient. Are we together, Lisa?
Yes, sir.
Okay, perfect. So finding gradient using differentiation is very easy. Differentiate the function and then put in the x value. Even if they give you the values or the point as a complete set of coordinates, for example, 5, 7, you will just take the x value and plug it into your derivative. Are we together?
Yes, sir.
Okay, so finding the gradient is very easy. Differentiate the function and then plug in the x value. Now let's get back to today's lesson in which we want to find the what? The turning point. So we have established that at the turning point, the gradient is 0. So we need to find the x values. So I'm going to do this. I'm going to just modify the question. Find the turning point of the curve. Find the turning point of the curve. Y equals x cubed plus 2x. All right, so that's fine. We need to find the turning point of this curve. Now, we need to list our steps. If you want to find the turning point of a curve, these are the steps you must follow. Number one, you differentiate. So number one, step one, differentiate. And in our case, we have our curve y equals x cubed plus 2x. And then dy dx will be what, Boipelo?
So would you use the same method that we did yesterday?
Yes. Whenever you're differentiating, you use the same method.
Okay, so dy dx would be 3
Mm-hmm.
x to the power of 2.
Good. And then for the next part, plus 2.
2.
Okay, so that's fine. So that's the first step when you want to find the turning point. And then the second step is to solve this equation. So you have to solve dy dx equals 0. Bear in mind that we already know our dy dx. Increase the thickness slightly. We already know our dy dx. Our dy dx is this guy. So we are going to solve 3x squared plus 2 equals 0. Are we together?
Yes, sir.
All right. And then whenever we're trying to solve this one, this equation won't work, but let's just do it anyways. So if we want to solve this, we're going to transpose it. So we have 3x squared equals minus 2, right? And then after
sir.
that, we're going to divide. So x squared is minus 2 over 3. And then for us to get our x, we take the square root of that, isn't it? So this x value will be your turning point. At this instance, don't try to punch it in the calculator. It's going to give you an error because we have a negative value there. Are we together? I just need you to know the process. So differentiate first, and then solve your answer, your dy dx equals 0, and then you get the x values. Those x values will be the values of the turning point. Are we together?
Yes, sir.
Yes.
Okay, so that's perfect. So now let's do this. If you need a screenshot, you can just take a screenshot, or maybe later on you can just look at the what? Or you can look at the video later on. So now let's look at this one. This is a typical question from the past paper, and we're going to implement our 2 steps. So step 1 is to what? To differentiate. And then step 2 is to solve dy dx equals 0, and then you get your coordinates of the turning point. So let's quickly do that. I'm gonna need Lisa. Or is Nehemiah here? Is Nehemiah back?
Yes, sir.
Nehemiah, how are you?
I'm good, sir. How are you?
I'm fine. So we're just doing differentiation, yeah. And I know Melissa will help you with this one. Uh, if you don't know about it, but just try to concentrate and follow along. Okay. So Lisa, I need you to help us differentiate this function because we said whenever you're trying to look for the turning points of a curve, you must differentiate, and then after that you solve the resulting equation dy dx equals 0. So let's differentiate. So y equals x cubed minus 6x squared plus 16. Lisa, can you tell us our dy dx, our answer after
So I have to do
differentiate?
the whole thing.
Yes, bit by bit. For the
Okay.
first part, what are we going to get?
So it's going to be 1 minus 3.
Okay, we just want the final answer. We don't want the working.
So I'm just asking just to be sure.
All right. Yeah, we're using what we were doing yesterday. You bring down the n, so 3 comes down. You write your x and you decrease the power by 1, isn't it? So you subtract 1
Oh,
from the
yeah.
power, and then we get that. And you're going to get used to that. So can you do the next term?
It's going to be 6 times 2
Yes, I want the final
minus 6
answer.
times 2,
Mhm.
which is going to be minus 12x to the power 1.
Okay, that's perfect. And then for this last term,
Is going to be 0.
yes, it's going to be 0. Whenever you're differentiating an element and there's no x, and then it becomes 0. So our equation is this guy. This is our answer after differentiating. And Melissa will give you the differentiation rule, and then yeah, you'll be able to take it from there. Now we'll move on to step 2. Now for step 2, we must say dy dx equals 0. We must solve this equation. So in our case, our dy dx is 3x squared minus 12x. We just have to equate it to 0 and then solve it. And then we'll get our values. All right, how can we solve this question, Boipelo?
So could you divide by 3?
Okay, yes, dividing by 3 will work. But if you look at it closely, it's more of a quadratic equation, right? So you can use either the quadratic formula or you can just do factorization. So let's just do factorization. I'm going to take out 3x, and inside the brackets, we will be having x minus 4. Are we together? Equals 0. And
Yes, sir.
then we'll split our brackets. So the first bracket will be 3x equals 0. This will give us x is equal to 0, even after we divide. Okay, if you get lost, please just tell me and then I'll take it slow. And then on the right-hand side, we have x minus 4 equals 0. And then our x is going to be 4. So we have our 2 x values. Are we together?
Yes, sir.
So these are the
So
x. Mhm.
I don't understand how you got 3x is equals to 0.
Okay, so whenever you try to solve a quadratic equation using factorization, you factorize, you create your 2 brackets. Just like here, we have our 2 brackets, this guy and this guy. And also you have that guy and that guy. And then after creating those 2 brackets, and bear in mind that the other side must always be 0. you take each bracket and you equate it to 0. The first bracket is equal to 0, and then you solve it, the equation. And then you take the second bracket, you equate it to 0, and then you solve the equation. So if we equate the first bracket to 0, we end up dividing by 3 to make x the subject. And we discover that x is equal to 0. And then for the second
Oh.
bracket, we're going to transpose this guy to the right, and then x will be equal to 4.
Thank you, sir.
All right. So that's perfect. And make sure you're constantly revising factorization and all those equations we've covered, we've done. All right. So now we have a problem. In our answer, they are expecting us to have 2 coordinates. We know that x is 0 and we know that x is 4, but we don't have the y coordinate for each one of these x values. So now our third step is to find the y values. Step 3, find y values. All right. So what you're going to do is, if x is 0, we need to know y, the value of y. And if x is 4, we also need to know the value of y. And where are we going to get y from? We use the original equation. So to get your y values, use the original equation. Are we together? So if x is 0, we know that y equals x cubed minus 6x squared plus 16. And then we know that y equals, now we do our substitution, right? 0 cubed minus 6, 0 squared plus 16, and our y is gonna be 16. You can use your calculators for that, and that's it. So if x is 0, we know y is 16. So right here, we're gonna put 16. Now we need to finish off the second set of coordinates here. We have the x value, but we don't know what the y value is. So we know that our x is 4 at the turning point, but we don't know the value of y. So let's write our original equation. So y equals x cubed minus 6x squared plus 16. Then y equals, we're doing substitution. We're taking 4 and then replacing all the x values in our original equation with 4. So 4 cubed minus 6, 4 squared plus 16. So y is going to be what? Can you use your calculators for that?
It's going to be negative 16, sir.
Excellent work. Thank you for that. All right. So if x is 4, then y is minus 16. And we are done with the process. So step 1, you differentiate. Step 2, solve dy dx equals 0, or solve your answer equals 0. And then step 3, you find the y values. If you do this, you're going to get those 6 marks. Are we together? Any questions on these steps? Melissa, are we good with this one?
Yes, sir.
All right, Lisa, are we good with this one?
Yes, sir.
Okay, so remember, these are the 3 stages that you follow whenever you're trying to find the turning points of a curve. And this question will most probably come. Boipelo, are we good with this one?
Yes, sir.
All right, so I'm going to give you a bunch of questions about finding the turning points. You always follow these 3 steps. differentiate, solve, then find the y values, and you'll be good. Okay, we're gonna use the rest of the minutes. I think we're left with 15 minutes to look at some of the other questions in this paper. And then if you ever feel lost, you can just refer to the video. I'm gonna upload it anyways. So that's fine. And let's look at this. We're just looking for the questions that we've done. We did mensuration of plane shapes, and we didn't cover the solid shapes. So very soon we're going to cover that. So we can leave that as is for now. Okay. This question requires the knowledge of sine rule, cosine rule, and maybe a little bit of parallel lines. We're going to cover that. Let's see. And those are trig graphs, and these are the functions. Okay. I think yesterday I gave you homework to do the functions. I'm gonna quickly do these questions so that you can mark for yourself. And for the sake of those who were not here. So I know Waipelo and Lisa, you've done this one. Did you manage to do these questions? Did you do your homework?
Yes, sir.
All right, perfect. So I'll be moving very quickly here. Melissa, we have functions for you. All right. So this is maybe case 2 type of functions. We have an equal sign. So what you're gonna do here, whenever you have an equal sign, you must try to find the expressions for each side. So on the left-hand side, we have f of x. Nehemiah, what is f of x? The value of f of x.
It's 2x plus 1.
Excellent. So we're just gonna take 2x plus 1 and we substitute it like that. And then here we have our equal sign. I'm gonna write the equal sign. Now the problem comes to g of 1. They want us to write g of 1 here, but they've given us g of x. So how do we find g of 1? So if g of x is x squared plus 4, then g of 1, can you see the difference here? Especially Nehemiah. Between these two boxes, what has happened? Spot the difference.
The values are different.
Yes. In the first box, we have x, and in the second box, we have 1. So which means we're going to interchange x and 1. We're going to substitute x for 1, isn't it? So in the original equation, they had x, but in the next equation we're going to replace all the x values with 1. So it will be 1 squared plus 4. And then, so g of 1 is going to be 5. Are we together?
Yes, sir.
So which means on the right-hand side, our g of 1 is 5. We're going to plug it like that. Now, all we need to do is to solve or make x the subject. So in this case, we're going to transpose 2x equals 5 minus 1, 2x equals 4, and then our x is going to be 2. Any questions on that one? All right.
No,
Yes.
sir.
All right. So the answer is going to be 2 like that. Now let's move on. I'm just going to erase this so that we get more space. F to the power of minus 1 of x. This means we need to find the inverse of f of x. And for you to find the inverse, I told you last time that you need to use a change of subject. So you have to write f of x But let's do it this way. So f of x is 2x plus 1. Now, you change the notation from this functional notation and just write y. So we have y equals 2x plus 1. And then from here, you need to make x the subject. So if we are to make x the subject, we have y minus 1 equals 2x. And then we have y minus 1 over 2 equals x. I believe everyone knows how to make subject. So this is our answer after making a the subject. The last step when you're trying to find the inverse is you flip the what? The letters. You just interchange them. Your y becomes the x, your x becomes the y. So x minus 1 over 2 is equal to y. And this y is our inverse. Are we together? So x minus
Yes,
1
sir.
over 2 is the inverse. X minus 1 over 2 is our f to the power of minus 1 of x. That's the inverse. So you make subject, you make x subject, and then you interchange the letters, you got yourself an inverse. I don't know if you managed to get those answers, but later on you must send me your answer sheets. Yes, Waipelo.
So 1 minus 1 over 2 would be the final answer.
Y minus 1 over 2, not y minus 1 over 2. Remember, we're going to interchange these values. Your y is going to become your x. So x minus 1 over 2.
So you have to change it back.
Yes. X
Okay.
minus
Wait, so
1.
why do we change it?
Okay, it's part of the rule. It's just part of the rule. So you make x the subject, and then you just interchange everything, because the inverse simply means the opposite. And all our functions are written in terms of x. Remember, here we don't even have a y. Do we have y there?
No.
We don't have y. Our expression has been written in terms of x. So our inverse must also be written in terms of x. So that is why we interchange that.
Thank you, sir.
All right. Now let's move on. I'm gonna erase this. We're left with about 5 minutes. Okay. So now we have, I don't know, I think I marked it as case 2, where we need to find gf of x. I'm gonna leave it like that. Okay. So if you have this, you have two letters, two functions, g and f, but they are side by side. This is what we call a composite function. We have a child function and we have a parent function. So let me just change the color of the child to be red. So the child is red, the parent is what? It's dark blue or purple, I don't know. Okay, so what you need to do is you have to do substitution. You gotta put the child in the parent, right? The reverse process. Okay, so you have to put the child in the parent. So I'm gonna write down the parent. So our g of x is our parent, and g of x is x squared plus 4. Now inside g of x, we are going to put our child. And where are we going to put our child? So our gf of x, our child is going to replace all the x values. So our child is going to affect the x element. Okay. So the 2 is not the x element. So our final answer will be something like this. So g f of x is gonna be our child here. Our child is f 2x plus 1. And then we'll write down the parent function. We have squared plus 4. What we just did is to replace all the x elements in the parent with the child. So this guy is the child. And then after doing this, you can just simplify it. So it's worth 3 marks, so you have to expand it. So we have 2x plus 1 and 2x plus 1 plus 4. And then we need to do our foiling here. We are going to get 4x squared plus 2x plus another 2x. That will become 4x plus 1 plus 4. I'm sure we all know how to do foiling, how to expand our brackets. And then after this, our final answer will be 4x squared plus 4x plus 5. Are we together?
Yes, sir.
All right. So for those of you who were not here when we introduced the functions, please make sure you watch the other video. And then that's it. So we don't have much time, but if you did this homework, I want you to send me this page with all your answers so that I can mark part D and part E for you. So that
Sir?
applies to Lisa and Boipelo. Yes.
I didn't do part D and E because I didn't.
All right. So for part D, let me actually give you a hint in the next minute. For part D, you must just find the inverse of H first. And then once you have it, you equate it to 0.5 and solve. Are we together?
Okay, sir. Yes, sir.
So you get a nice equation there. And then for part E, we'll do that one together. I'll just
Okay,
do
sir.
I just do that with you together. And then tomorrow, I'm sure tomorrow is Friday, and then we'll go over this one. I'm
Sir,
gonna, yes.
on Fridays on the timetable, it says that we have assessment, so we can have an assessment too.
Yes.
Okay,
So
sir.
your assessment will be basically on functions and just the first part of differentiation, not what we covered today.
Okay, sir.
The basics of differentiation and the basics of functions, because those are the two
Okay.
topics we did this week, and that's fine. So tonight you must just be on them, and yeah, I think everything will be fine from there. But bear in mind that you need to be constantly revising all the other topics that we did, all the other topics, and yeah, we'll try to make it work. We're gonna have sessions where I'll be just doing the whole paper for you and you'll be watching, and that's it. All right, I think that's it for today. Enjoy the rest of your day. I'm gonna send the